get a few things out of the way. So I gave us the same talk a couple days ago at Go to Amsterdam, which is a great conference, but it's not really a Java conference, right? So I was kind of hesitant about the talk because this one is all about modern Java features, but it's importantly, I'm not going to introduce them carefully. I'm not going to teach you how they work. If you don't know how these new Java features work, I mean, if you don't know anything about them at all, you might feel a little bit lost. And that's okay. I'm not here to teach you those features. I'm here to show you those features. So you look at them, you're like, holy shit, this is crazy. This is Java? Okay, then you take it home and then you look deeper. So if you know them already, you'll recognize them. If you don't worry. If you feel lost, it's not because of you, it's because of me, right? Okay. Yeah, let's not go there. So, you know, another thing to pass the time, I'm always curious about Java versions that you're running. And of course, I would love for all of you to run new Java versions. So I'm going to ask the question in a way that's totally in my favor. I want to ask you, what is the newest Java version you run in production? So if you're working for a bank and you got like tons of Java 6 around, but you have like one internal app that tracks your vacation days, and that's in Java 21, raise your hand for 21. Okay, that's how we're going to do this. Well, no, not yet though. Okay, so let's start. Who runs something before 8 as their newest version in production? Okay, now here comes the thing. I'm going to ask about 8, and yesterday, Utrecht Jack blew me away. Nobody raised their hand. Everybody had something newer than 8 in production. So you could spoil this now, but you know, maybe Utrecht does the thing again. So who runs 8 as the newest version in production? Okay, a few people, a handful. Well, that's cool. So 11? 17? That's so far the vast majority. And 21? Almost as many. Okay, yesterday was a little bit more cutting edge, a little bit more 21 than 17. But okay, that's really cool, by the way. I really appreciate that. Anybody running 22 in production? Come on, somebody. Yes! Robert, you don't count. Your production is your machine at home, right? Yeah, that does not count. Yeah, so for those of you who went from 17 to 21, you might have noticed it didn't really break your back, right? It wasn't that terrible. Now imagine doing a quarter of that work every 6 months. Maybe it's not that terrible. Maybe you could, maybe you could get into it and consider if you have, if you're running in the cloud and your cloud provider does offer you Java 22 or 23 soon, maybe you could give that a try. Okay, I think we're there all. Let's get started. I didn't introduce myself. I'm Nicolai Parlog. I'm a Java developer advocate at Oracle, and today it's going to be you, me, and modern Java in action, as I just described. The in action part is really important here. So let's get started. We'll implement a little GitHub crawler. I'm going to get to later what exactly it does. We'll aggressively use, abuse, and overuse modern Java features. So if you look at this and be like, why are there so many vars? Why is everything a Lambda? I would never code like this. That's fine, right? It's okay. Like, you can scale it back a bit. To discuss with your team where you think this makes the most sense. As I already explained at length, it's not a showcase. It's a showcase, no tutorial. If you want to dive deeper, there are tons of resources. The number one then, if you want to learn from somebody talking to you, me or one of my colleagues, go to youtube.com/java, and you will find a lot of videos about all of these features there, going into varying degrees of depths. So I can already recommend that. The code as well is online at github.com/nipafx/modernjavademo. Do read the README. It's very short, but do read it. Without it, you're going to be lost. And you can ask questions here at any time. So that's okay with me, right? And if I don't look up because I'll be coding, looking at the screen down there coding, just yell. If you have something that's very urgent right now, feel free to interrupt me. Okay, let's talk about the GitHub crawler that we're going to implement. The goal here is to connect to a seed URL. It's probably a GitHub URL, but it doesn't really have to be. But it probably should be a GitHub URL. And then we identify the kind of page we're on. If it's an external page, we don't do anything. But if it's a GitHub page, we try to figure out what's the interesting block, not the header, not the footer, the part in between. Look for outgoing links, pour the outgoing links back into step 1, and then probably should count the depth or something so we don't end up crawling literally all of GitHub. Then we do some operations on that. We print some statistics, we print a page list, and we want to show the results on localhost. Now these operations are super simple because I don't have a lot of time and I don't want to bore you with like doing something actually worthwhile because that would take too long. But these are stand-ins for more complex operations, right? So these are stand-ins for maybe you want to do mood analysis, or maybe you want to show an interactive graph, or maybe you do something and then you want to bill people for it. So there could be all kinds of operations built on this that are way more complex. We're going to build the domain model with records and sealed interfaces, and we're going to build the operations external to those records and sealed interfaces, and we're going to use pattern matching to identify which type we have and to take things apart. We're going to be fetching pages from GitHub with the HTTP client that was added in Java 11, so no URL open connection, all that crap is gone. I mean, it's still there, but you don't have to use it anymore. And we're going to use virtual threads via structured concurrency. This is a little bit of a blink it and you'll miss it feature, because as rarely as we nowadays really interact a lot with threading and thread pools, most of that is isolated in some part of the application. Same will be true for virtual threads. Virtual threads are great, but they're not a feature you're going to encounter, you know, like lambdas or like streams maybe every hour that you're coding. We're going to present the results with text blocks and with string templates, but that thing is struck out because string templates went the way of the dodo in JDK 23. So if you experimented with string templates in 21 and 22, they are gone in 23. The preview didn't succeed. There will probably be a new version in the future, hopefully. Let's cross fingers. But that's why we skipped that step. And this text blocks as well, we skipped that because that's kind of boring. And then we'll host all of that with a simple file server. We're going to create some HTML file, and we're going to host it locally to take a look at that. And of course, I'm going to use modules for reliability, because it's kind of my MO here. OK, so let's write some code. Let's have a look at the code base. It's super small right now. It's just this GitHub crawl method that doesn't really do anything. So let's start. Let's create some domain models. So we're going to start with, let's say, external page. Which is going to make a record. And what do external pages consist of? They're going to have a URL, and they're going to have some content. And as I said, we're going to track links, but not for external pages. For external pages, we don't care about links. And if you create a simple record, you're already done. We create the record, we define the components, we get fields, we get accesses, we get a constructor, we get all of that. We don't need to do more. But what is important if you deal with data like this, you really want to make sure that the data is in a good state. So we want to verify stuff. So let's create a compact constructor and add some verifications, like we want to make sure that the URL is null, for example. And then the same probably for the content. And then maybe the content shouldn't be empty. Right? So if the content is blank, then I'm going to throw a new illegal argument exception. There we go, stuff like that. Right, so this is stuff you want to do, this kind of verification that you want to add. And in this case, we did use the compact constructor where you don't have to put the parameter list there. That's a feature that records have. Another thing that you might often want to do is you will often want to define equality in a different way. So the equals and hash code we get for records is really good. It uses all the components, so it's much better than what object gives us. But in this case, we have something like a unique identifier for the page, right? We have the URL, and if I remember correctly, the U does stand for something related here. So let's try to write an equals and hash code implementation for that. There we go. So this generates an equals and a hash code. That's kind of nice, but we can actually do a little bit better. So I'm showing you two things here. I'm showing you here that you can customize all of the things that records give you for free, but we can also now use an interesting little type pattern to make equals different. And I really hope that IntelliJ will sooner or later allow that by default. Okay, so this is the other object kind of check that we always do, and now we do the instance of check. We say other could potentially be instance of external page, in which case we're interested in this comparison. And now we define a new variable. Let's call it ext. And only when this check is true will this variable be available. So since I'm going with an and there, that means if I'm down here, the instance of check must have completed, so I can use the variable. So I can say, in this case, the URL equals my URL. Right, so that's a little type pattern. We're going to see way more patterns later. Okay, let's create one other type. Let's do the GitHub pull request page. Okay, so again, we have the URL, and we have some. Well, I'm not the best typist, as you might have noticed. Okay, and what we want to do here is we want to have a set of outgoing links. For now, we're going to create a set of URIs. Later, we're going to replace the type UI with something else. That's going to be our links. And then we're going to have a pull request number, right? And records, when you deal with records, your default should be to make sure everything is immutable. Now, these fields we get for the URL, content, links, whatever, they are not reassignable. And a string is immutable. The URL is immutable. The int is immutable. So that's all good. But the set isn't. Somebody could hand us a hash set, and then that code could hold on to the reference and change it. Or worse, it gives us a hash set, and then the links accessor returns the hash set, And then everybody who calls .links on our GitHub pull request page can just change things, which we don't want. And unfortunately, Java does not have immutable, like collections that are where the type tells you that they're immutable, but it does have implementations that are immutable. So let's create a compact constructor. We want to have checks as well as before, but now we can do things. We can say, for example, we want to create a copy of that set. And these copy of methods that you find on link, list, set, and map will create immutable copies. If you have other data structures coming in that are not immutable, you might have to do some more work. Maybe it's your own data you have to look out. If they are mutable and there is just no immutable variant of those, then there are some other tricks you can do. I'll leave you with some links to, give you a link to a blog post later that explains a little bit more what you could do. But the point is, by default, you want to make sure everything is immutable. We'll later diverge from that intentionally, though. But by default, everything should be immutable. OK, and again, we probably want to override equals and hash code here, but let's not go there. OK, I'm going to cheat now. Instead of coding everything, I'm going to check out a good version of the code that also means whatever mistake I just made is now gone. Now we have these 4 records, which represent the 4 kinds of pages that we have. If we connect to something, we want to connect to GitHub. And right now, we kind of assume GitHub only has issue and pull request pages for the moment. And then we could also link to an external page. And of course, there could always be a dead link, a 404, whatever. So we also have an error page. And that's all the data we want to model. And we've done that. But there are additional relationships here that I mentioned while talking about it that are not expressed here. Specifically, we have a lot of either-or relationships. So let's say we create an interface page. And now the normal way to do things would be to just say, well, look, every page has a URL. All of those 4 classes implement that interface, and we're done. But we can do more, because we know that for now we only want to track those 4 kinds of pages. So we can create instead a sealed interface, and then we can say which types are actually permitted to extend this. And if we try to connect to a page, it will either be successful or an error, right? Error page. There we go. Successful page. Wait, that's the wrong way around, right? Is this correct English? Oh, so it's double C as well. There we go. OK. This still looks wrong. Let's leave it like this, even though I think it looks wrong. Anyway, right. So now we have made a sealed interface. We permitted 2 subtypes. Error page already exists, so that's good. But successful page doesn't exist, so let's create one. So that means we had a successful connection with a page. And this one could then what? What could it permit? It could permit either it's an external page, right? We already have that one, or it's a GitHub page, a type we don't have yet. And then here, every successful page has a content, right? So you can see that you can iteratively define the contract here. But the important part is that we keep going this idea of, are there either-or relationships here? And every time there is an either-or, we use sealed types, or specifically sealed interfaces, to express that. Actually, I want to create an interface, though. So let's do that. There we go. And this one permits the GitHub pull request page and the GitHub issue page. And this one will then have the children. And now that's interesting, the links, right? We had this before, but we didn't know what type to use here. Now I do. We can actually use a set of pages here. OK, now this is all broken. We still have to go here and actually implement the interface. And now this lines up. The interface defines it needs a URL and it needs content, and this matches the accessors that the record creates, so that's good. But here the types don't line up, so we have to go page here. And now we have to go through all of that to make all the relationships work, but that's just straightforward. The important part here is that we now not only modeled the data, but we also modeled how it relates to one another. It's either this or that, and that will become very important later. OK, so that was that. Oh, there's one more thing actually that I can show you. I'll cheat a little. I'll steal some code that I have on my notes in front of me. And what I want to show you is, let's go to the GitHub page type. So this type here defines that that it has links, that it's outgoing links. And what we can do is, so we have a page here, and it links to other pages, and we can see this as a tree. It's really a tree because it can have backlinks, but we're going to ignore that. Let's assume it's a tree. What's really handy if we can stream through that tree, right? So if you just say, OK, given this page as a root, let's just have a stream that contains all the pages that are being linked here. And the implementation is not exactly trivial. Reason being that we have to count because of the backlinks, we have to make sure that we don't report anything twice. So there's a little bit of work here. I don't want to bore you with any of the details. I want to show you 2 explicit methods that I'm calling. One of them is remove first, which I'm calling on the linked hash set there. That method you might not have seen before. And then down here, I'm calling reversed. Again, that is a linked hash set I'm calling that on. And those are methods that were added by sequence collections. Sequence collection is an addition to the collection API, which captures the concept of a collection that has an encounter sequence. All lists have that, right? All lists have an order, and they're always, always see them in the same order. But a set doesn't. But a linked hash set does. And a sorted set also does. So some sets do, but some don't, and all lists do, and some other collections maybe do or don't. But it's really handy if you know that you have this kind of sequence, because you can do stuff like reversing it. You can do stuff like removing the first element or adding the last element or all kind of stuff, right? So it's good that these methods exist now. So if you are on, I think 22, right? Oh, that's the wrong button. Yeah, 21. Sorry. If you are on 21, you see reverse what was added on 21. So you can, if you're on 21, you can already use this stuff, and it's really handy. It's not a revolution, but it's really handy. Okay, good. Now we got the domain model going. Let's start to work on our operations. So the way this works is that if we're here and we want to create a pretty name for a page, then we want to do something like if it's an error page, we want to write error, maybe with an emoji, but the emoji is going to come from the Git commit because I don't want to type out emojis here. But if it's an error page, we want to say error, and if it's a GitHub page, you want to maybe say it's a issue page with the issue number, all that stuff. Usually, you would put a method like page name on the interface, right, on the page interface. But I said, imagine this is a stand-in for a more complex operation, an operation that wants to be external to the interface. Something, the mood analysis. The page should probably not talk to the ML-based mood analysis subsystem, and then also to the invoicing system if you want to, build users for your mood analysis. No, probably both of these subsystems should operate on the page. So what they get is a page instance, and now they need to figure out what kind of page it is. And the way to do this is to use pattern matching. So we're going to switch over the page. And now what we need to do now is we need to address each individual type. So let's say it's an external page. Let's say ext. And then we can say external. And you can see this would be a place where a string template maybe could be used. But anyway, let's go with, I don't know, the URL host or something. Something like this, right? OK. And we can keep going here. Let's do this. Let's say it's an error page. Error, and then, I don't know, I think we get an error exception somewhere, right? There we have an exception, we can get the message. That would be OK. And then we do the GitHub issue page. It's going to be an issue. Oh, right, and then the number here, and then the issue number. And let's see, let's copy paste this for the pull request, because it's basically the same thing. PR, that's a PR, and that's also PR here. Well, did it really help to copy paste? I don't know. Who else copy paste stuff and then feels like they're doing more work, reworking the? Is it just me? Oh no, thank you, because I do this all the time. But I rewrote the entire line. Okay, so what's important here is if we copy this, if you comment this out, you will see there's a compile error. I hope you can see this. There's a compile error on page. So the compiler is not happy, and the reason why the compiler is not happy is because I have not listed all page types. It knows that starting at a page, there is more types here. There's something missing, because not only we can express for ourselves and our colleagues that a sealed interface has only these possible implementations. The compiler understands. It builds this tree and understands when have we covered all possible cases, when have we exhausted all possible cases. And so this is very, very important. This makes this switch safe, because that means when you ever add a GitHub commit page, you will once again get a compile error here. So this little compile error is very crucial. OK, there we go. Another thing we can do is we can take this stuff apart. So let's start with the error page here. Let's say, so the error page has, what, a URL and then the exception, right? Oh, sorry, there's a little typo here. There we go, with the exception. And then, there we go. Oh. So we say, look, if you're an error page, just take it apart, give me the URL and the exception directly, and then we can use that. And you know what? The URL is unused. So that's lame. And if you're on 21, you can use this as a preview feature, It has not changed and was finalized in 22. So you could use it in 21 with enable previews. If you do decide, just a warning, to enable previews for these features, which generally is not the best idea, but there are good reasons. Like if you do it carefully, you can do it. It's a separate conversation that we can have. Just be aware that Java 21 has a ton of preview features, and if you enable preview, you not only get this. Now everybody can use everything, which is not great. Anyway, so what we're doing here is now saying, take the error page apart, give me the exception, ignore the URL. What's really cool about this is that if you read this code, and if I would go through the trouble of doing that everywhere, the left-hand side tells you what I'm interested in, and then the right-hand side tells me what's being done with it. And that's great, because if you're looking for a bug, or if you're looking for the place to insert your feature, you're like in scan mode, right? You're not reading every line in detail, trying to figure out what exactly is happening. No, you're trying to figure out where code is flowing and what is happening, and I think that's a really clear structure to read there. Okay, now we want to have a list here. So what we want to do here really is we want to say, take the root page, and then we have the subtree method, but oh no, it doesn't exist on root page. True, it only exists on page, so we would have to do something like an instance of check. So if the root page is an instance of the GitHub page, then we can do this. GH page subtree, that's already a stream, so now we can map with the pretty page name, and then we want to join this with a new line, right? Okay, now let's do something nasty. Again, use, abuse, and overuse, right? So So what have I done here? I've said if it's not a root page, oh, I forgot a semicolon there too. If it's not a GitHub page, then return just the name for that page, right? But otherwise, if it is a GitHub page, and this is where the weird part comes in, I told you earlier this variable is in scope everywhere where this check is true. Well, down here the check is true, right? Because if it was false, we already escaped the method. So down here it is true, and so accordingly I can use the GH page variable down there. That's great. Lets you feel really smart. You will get a lot of questions in code reviews. So if you enjoy this kind of interaction, I can only recommend doing this. I'm pretty sure that the world at large is happy with the fact that I don't code in a large team anymore, because I will definitely commit this kind of code. But yeah, so anyway, you can do things like this as well. Good, we can do the same thing for the statistician. We're not going to bore you with doing more of that. I hope that this is the pattern matching and the switch, and that we've worked that out, how that's supposed to work. Okay, let's keep going, and now let's do more of the actual crawling. Now, a lot of the code is like the code needs a lot of, not a lot, but a decent amount of like infrastructure and shuffling things back and forth, and that's already there, right? So we're now entering code that has a bunch of compile errors, and what we need to do is we need to fix them. The first compile error I want to fix, because it takes us a little bit back to the records, is something like page with links. So far, I've used records as the fundamental types in my domain. I really cared about them. I made like checks in the constructor and the equals and hash code and all of that. But records are also really, really great if you just need a quick type, like a tuple, right? Well, Java doesn't have a pair. Whoever used the map entry as a replacement for pair? That was evil, and you shouldn't have done this. I did it too. Now you can have a record like this, page with links. What page with links is, it is what it says. It just needs, so I need this while I'm collecting the links, right? I already created the page instance, but the outgoing links set is empty because I'm still collecting that. So I'm still saying, I'm still collecting the URLs. So let's just do that. Let's just have this type here. There you go. And that could be it, right? Actually, I want to make sure this one is not part of any API. It's just package local, could be internal record, could even be, you can even create records within methods. I mean, you can do this with classes too. Did you know they can do this? This is valid Java code. Don't do it though. But you can also do it with the record. I did not know this. But so what I'm saying is, like, if you can also have throwaway records, right, where you don't put in that much effort. That's fine as well. And in this one, I already know I need a constructor that does not take the links. So let's remove that one. And there we go. Oh, right, this does not work. Now we have to call this page, and then let's create an empty set. So you can also add constructors, of course, new ones if you want to. Records always have to call the canonical constructor eventually, though. You always have to put it this here, which I think is a good choice. Okay, so let's fix this one of the compile errors. Now that we leave the record and pattern matching behind for a while, let's do a few other things. So let's start with looking at the import errors that I have here. And I got an error on the import. Who has an idea what this, I mean, if I hover over it, IntelliJ will tell me, but who has an idea what this error could be about? Yes?
Regarding the modules, not imported?
Yes, regarding the modules, that's not imported. Great, who else would have spotted that? You need to use more modules, my folks. But that is absolutely true. So I have a module info here, and the module info does not say that it has any dependencies. Again, IntelliJ is smarter than me, already telling me that I'm doing this wrong. So yeah, and some people say about modules so complicated, you have to put everything twice. There we go, done. And there's one more error here. It's the same thing. I'm using the HTTP client, the new one, which also is in a separate module. So let's add a quick import for that as well. Again, that was all the module work we're going to do here. So I think that, you know, it's not that terrible, right? Let's start working on the HTTP client. Let's start fetching some pages. In GitHub crawl, I'm creating a client here, an empty null HTTP client. I haven't created yet. So let's do this. Let's create an HTTP client. The HTTP client, the request we'll see later, those are all created with builders, and they're all thread safe. So the idea here is that if you have a recurring kind of HTTP configuration that you use, create one client, and then spread it around your system with dependency injection, however you want to do this. Everybody can use it in different threads at the same time. It's no problem. So let's create the one HTTP client we need. Let's create a new builder, and now we could configure all kinds of things: authentication, connection, timeout, cookie handling. We need none of that here. That's all fine. So we can just build. And in fact, if you're using this simpler approach, you can actually just shortcut to new HTTP client. Okay, good. So now we got an HTTP client that doesn't has no specific configuration. Let's use it. Down here, the task is, given a URL, connect to the URL, fetch the body, the HTML, and then return that. So what we want to do here, kinda, is return client dot, and then we want to send a request. You know, we need to get the request from somewhere. And then we want to return the body. That's, you know, more or less what we want to do. It doesn't quite work like that, but okay, let's start working on the request. As I said before, this one also has the builder pattern, and you can then here, if you need to, override many of the things that you've configured for the client, right? So you can you can add headers, of course, but you can also add cookie things somewhere, I think. You can add timeouts, so there's lots of things we can do. I think for us it's enough to say get, oh wait, and I need to set the URL down. Get from this URL, and then let's build it. And now we're almost done. The HTTP client is aware, though, that sometimes a request body or a response body is just too large to just turn into, to just handle in memory in one thing. So it allows you to do something with like reactive streams to like handle, like maybe you get JSON back and or CSV file and parse into each individual line or whatever. So it allows you to treat that body in different ways. So we need a body handler instance here. And there's the utility class, body handlers of string. And this just means turn the bytes into a string in memory and give me the string. And because this body handler is of the generic type string, then body returns a string. That's why the types line up here. Okay, that's how we fetch that stuff. That's all good. Now let's use structured concurrency to do this in parallel for all the requests that we have. So what we have here is, now we're getting a bunch of links, and we want to return a bunch of pages. And we have the depth here. That is the way that we prevent us from parsing the entire, fetching entire GitHub. We don't need to do the -1 here. The -1 happens somewhere else. So we just need to pass this on. So what we kind of want to do is, you want to say links.stream, and then we want to map each link. And now I think the method is called create page. Yes. So we want to, well, you know, let's call it URL. Maybe that's better. URL. And as I said, we pass on the depth. And, well, then we want to turn this into a list, and we're done. And we want to return a set. But it doesn't work anyway, right? So this would be like the simpler approach that we want to do. For all the links that we have, call create page with it, and then be done. But the problem with this is, and you can already see that the exceptions don't quite line up. Create page throws an interrupted exception and an exception. Both of those, oh, you can see that up there somewhere. it throws an interrupted exception because create page is a blocking call, right? It relies on the code that we just wrote up there. It goes to the network socket, opens it, and then says, okay, I'm waiting for a response. So this way to implement it would do one after the another. So that's not great. So now, as I said, we want to use structured concurrency to fire them all off at once. And we're going to use a structured task scope, and a structured task scope is going to create a virtual thread for each task that you submit. Okay, so we're going to have to create a try with resources block because that ensures that the scope is going to be closed when we're done. Structured task scope. We're going to use the one that shuts down on failure. So if there's any error happening, we're going to just shut down the entire thing. Okay, so that's that. Okay, now this almost works. The create page call, instead of doing it blank, like doing a naked call here, we're going to fork it. We're going to tell the scope for each link, please fork a new task, and in this task, create a new page. Okay? So this happens instantly. It's just firing off 8 tasks or 10 tasks, however many links there are, and that's all. I see a few people creating their next. Maybe I can go further up. Okay, that's the furthest. Let's add some new lines here. Okay, there we go. Okay, so that's good. We've now fired them all off. Let's store those. Now we tell the scope to join. We're going to now wait. And if there are any errors, we want to throw those. That means we're going to need a catch block. Yes, so, to do error handling later. There you go. It's not a good indicator. They were all laughing about this. But anyway, I guess we've all seen this before. Good, so at this point, that means we didn't have any errors, and all the tasks are done. So now we can fetch the results. So now we go to the tasks, stream those, and then we map a subtask has a get method. There we go. We just get the result out, and then we turn this into a set. Okay. Now, this has a few interesting properties. One of them is that create page, which was somewhere up there, which does the actual creation of the page, that's the actual domain logic, is entirely free of any threading concerns. There is no reactive pipeline there. There are no, semaphores in there, whatever you want to have. None of that is in there. Create page just looks like domain code. So that's good. We've put the entire concurrency in this method. This is what structured concurrency is about. When the flow of execution branches into several concurrent flows, then in structured concurrency, it needs to join in the same scope. So within the same method, we're going to join all the methods, and we're going to be done with concurrency. That's good for maintainability and readability of the code. Another big advantage of this is all the threads that I'm creating here, they're all children threads, right? So the thread that executes this, that then goes into the try and then blocks in the join call, that one is waiting while all the other tasks are doing its thing, and will only continue once they're all done. This is a relationship that you usually don't have between threads, particularly not if you have a thread pool. Right? The threads in the thread pool live indefinitely, and the other threads live indefinitely, and they kind of like meet like strangers in the night, passing on messages and results, but there is no strict parent-child relationship there. But here it is, and that can be really, really handy. I'm not sure, did I fix all the mistakes already? Oh, right, this doesn't actually work because it doesn't return a result. This shouldn't happen actually, because error page should have handled this. There you go. I heard earlier that typos are no problem. I hope that applies to my code too. Handleable. Okay, there we go. So this should not actually happen. So I think now we're rid of the compile errors, and that means we should be able to run this. So let's give this a try. Yes, stop and rerun. Okay, so it's doing things. It says resolving. It resolves some URLs. It occasionally will say found cached because there are backlinks to the same page. So we'll not catch them again. And once it's all done, it will print some results sooner or later. Maybe I should have taken Brian up and plugged in the cable. There we go. Okay, so it's all done now, though. Okay, so that's nice. It works, and it maybe even printed some results. Let's see. Yeah, there we go. That was, oh, right, the code that we checked out actually does use the emojis, so that's good. And then we have some statistics up there, I guess, as well. Where was it? Somewhere here. That was the statistics. Okay, so that's good. Now I want to show you the parent-child relationship thing, because at the top here, there was this message that is up there to see virtual threads in action, run this, blah, blah, blah. Okay, so let's try this. Unfortunately, I'm not fast enough to run this, so we need a breakpoint to make sure we stop at some point. and I think GitHub issue page, we can just put a breakpoint here, and then say, I think the magic number is issue number equals 740. So I just need any random breakpoint, right? So this stops at some point. Okay, let's pull this up a bit. We're going to work with that. I want to run this J command soon. Oh, nah, damn it. Console J command. Let's run it. It's not going to work now because the application is sleeping. Okay, so now it should have done a thing. Yes, it created a threads.json. Let's have a look at threads.json. That's a thread dump. That's what these kind of things look like, right? So every thread that's running in your application, you will now see their stack trace. This is a good stack trace already. You see that this one is doing something in my page tree factory, and then there's a structured task scope here, and it sits in the join. This is actually a thread that sits in join and waits. And then there's other things going on here. This is actually an interesting one. So let's pick this one. I'm really happy that by accident we opened the file here. So this is thread ID 64. All the threads that it started say that they're owned by 64. So we'll find a bunch of threads. Well, we find one thread apparently, but there could be more. And for other, there are more. So you will find that every thread that is currently doing something, every virtual thread is, or most of them, are spawned in this block that we just wrote, right? And that means they all know their parent thread. And you can navigate that. The IDE doesn't support this yet. But that means if your entire application runs in virtual threads, and you put a thread dump, you have to do a thread dump, or you put a breakpoint somewhere at the very bottom. And you know this problem, right? You're debugging, you're going up the stack trace, you're trying to figure out what's the context here, what went wrong, and then you end up in one of those stack trays, which like, I'm in a thread pool. And what do you do then? Like, you've lost, right? You cannot go outside of that thread easily to rebuild the outer context. But if you have virtual threads all the way down, you absolutely can. You can go from every method, from every stack that you have, you can go all the way to the top, and if you haven't found enough information yet, you will see, oh, there's an owner thread. What is that thread doing? What is that thread doing? What are those children threads doing? And that way, you can rebuild the entire context. And if you want, and your web framework, for example, supports virtual threads all the way down, like Helidon does, you can go all the way back to the virtual thread that is currently reading the socket, the network socket, where the information is arriving, which is crazy, right? This gives you the full request that you're handling right now as a context that you can use to find information instead of just the one thread that you're currently in. And I think once IDEs support navigating by this will become as important as navigating and clicking through a stack trace. Not quite, because most cases you will find the information in the stack trace, but you have the chance now to go further than that, which I think is really cool. So we're looking forward to being able to do that. Okay, step 3 would now be, so we're counting backwards, right? The countdown. Step 3 would now be string templates, but we're going to skip that one for reasons that I've mentioned before. So now we're going to wind down. There is not that much to do anymore. If we run the application now, oh, right, we're getting, oh, did I? That is weird. That shouldn't have. I'm mildly surprised that I had to fix an error here. Okay, let's run it again. We got something new here, though. We got the surf directory, which comes with the style.css file, and also already generated an index.html file. So the code now, once it's done, and the list that it prints down there, it will also write this to this index.html file. And this is where string templates would have come in, but we don't have those. But what we can do is we can go into surf. Okay. Oh. And then we can run JWebServer. JWebServer is a binary that comes with the JDK now. It's just a small web server. It's already in use. Okay, there we go. And now we can go to localhost 8081 and see this output. So this web server is there for demonstration purposes, for testing, for experimentation, for getting things to work. It's definitely not meant for production. But that's really nice. So by the way, the presentation that I'm the presentation that I'm giving is also an HTML file, and I'm also running on localhost, so that's also JWebServer running this. So I've already used this tool. Like, this is already my most used Java binary, at least used directly. I don't type JavaC that often. Right, but we don't have to do this from the command line later. We can also do this programmatically. So if you need some quick way to present something in an exploratory project, or maybe you're just looking at, you just wrote a tool that maybe internally helps you with seeing some information. A good way to present is to write down an HTML file and then launch a simple web server. So let's do that. Let's launch the simple web server. Let's do this here. So I can show you is a simple file server. You want to create one. We need a new inet socket address. Do I go with 80 again? I'm not sure what was running there. Let's go with 82. What else do we need? We need, oh right, the directory. So this is being handed in here. This is a server directory, and you have to do to absolute path or it won't work. And then we have to give some output level. I think info is fine. And this time, because I gave the talk just 2 days ago, I'm smart enough to actually call start on it. Because if you don't, it doesn't, and then nothing much happens. This is not magic. It happens what you would expect. It now runs out of this, and then will open it will open the file server and host the files on, in this case, 8082. So yeah, once again, Java is, as I said, virtual threads, pattern matching. Those are all kind of big things, but also Java is improving in many small ways. JWebServer, the simple file server, the sequence collections, all those things are also being improved here. Okay, I think. Let me see. I think I might actually be done here. Okay, so, this is the web server that's still running. Do we need to go to 8082? You probably trust me, right? That it's working. No? People are doubtful? Okay, yeah. Let's see. It's actually interesting because the order will change. Yeah, because the order here depends on how fast GitHub responds with the pages and which virtual threads run first, and we put all that in a set, which has no stable iteration order. So when I hit @5 now, it's stable. But every time we rerun the program, the results will look slightly different. Okay, good. I feel like I should be done now, but why are we not in? Oh, right, yeah, it's because this step is new. Okay, good. So far, what I've been doing is coding in my IDE, right? And for a project of this size, that's probably sensible. But what occasionally happens, you start small, maybe you SSH'd into a remote server, you only have a text editor, or Visual Studio Code, you don't quite have the plugin set up yet, or whatever reason, you're a beginner and you didn't want to deal with this yet. There's so many reasons why you might not have a full-blown IDE at your hand. I think in the majority of cases, people will have an IDE, but sometimes they don't. And so let's close IntelliJ, and let's see what we can do without. So let's go to the terminal. Let's make sure we're using Java 23. And then I'm going to show you what the source tree looks like, which is this, right? So this is source tree we just built. We have the module info Java there, and we have GitHub crawl.java there. That's the source file that runs the program, right? So what happens if I throw this here? Okay, actually, the code completion is terrible, so let's use a different command to get in there. Def, and then GitHub crawl. Okay, now let's replace it with Java. So I'm throwing the source file at the Java launcher. And what I'm getting is, I don't find JSoup, which is really cool, because this error comes from the module system. So it somehow discovered module info Java, parsed it, read it, interpreted it, and then says, wait, the file is missing though. Okay, good point, the file is missing. Where do we get jars from? That's a very good question. I don't have an answer for that. I'm using Maven. So that's actually a hole in this whole story still. I hope that will be plugged soon. Now we have a jars folder that contains a JSoup. So what we can do now is we can run the same command and say -p jars. And it's not going to work because we're using preview features. Okay, I need to enable preview features. And this then now becomes a little uglier even. Oh, enable preview, because my app now also needs command line flags after that, which, yes, okay, I need to add all of those. Let's not do that. Let's try to find in the history some past command that has all the flags. There we go. Okay, so this is good. And now it runs. So notice that I typed this all up potentially in some kind of text editor or whatever, but crucially, I didn't need an IDE to build it or to run it, to get a launch configuration, to find all of that. No, all I needed is a downloaded JDK and a text editor, and I can start working with stuff. I can write a single source file, I can write multiple source files since JDK 22, I can have dependencies here. This is great for learners, for exploration, for that kind of stuff. Okay, how am I doing on time? I got like 5 more minutes, I was told, because I had to start late. So let's use those to get over the final slides. Okay, so that was a lot. What did we do? First, which Java version did I use? 23 with early access features, but almost everything I showed you, you can use on 21. These are the exceptions. Multi-file program launching is only possible since 22. Unnamed patterns are only final in 22, and the structured task scope is in preview in 21 all the way to 23 still. Everything else was final. We created the domain model by using sealed interfaces to model alternatives. We used records to create the types exactly as we need them. We created this inheritance hierarchy, and I want to point out one more time, this is a closed inheritance hierarchy, right? If we have a page type, we know it must be one of those types. This is not like the collection inheritance hierarchy that you might occasionally see, for example, or your own code bases, where there can be arbitrary new implementations everywhere. This is fixed, and we've leaned on that when we've done the pattern matching because we needed the exhaustiveness there. We used an HTTP client to do the request, which was really straightforward. None of that, open on the URL was really straightforward also to get the response body and everything. We used the structured task scope to first fire off all the tasks, wait until they're done, and then collect the results, putting the entire concurrency into this one scope, which is what structured concurrency really wants us to do. We launched a simple file server, and we launched the source code program with java-p plus a lot of extra things. We can do more here. I promised you JPackage in the abstract, but I can't use JPackage because my Linux distribution is not supported. I found that out after I submitted. So I have some screenshots from José's exploration of that feature. He's on Windows, so he created an exe file here. So he uses JPackage to create a Windows native installer. Here he's installing, super thrilled. Those Windows people like they install bars and everything. That's so cool. You can do more though. You can do file associations, for example. So in this file, these are all the command line flags he will be passing to JPackage. And he says, look, there's an association properties file. And the association properties file says, if the file extension is .duke and the MIME type is a JPEG, then associate this application with it. And it works. Windows does its thing, and now you can double click on the Duke and get the Duke viewer. You can do more. So Alina, my colleague here, does a lot of does Graal a whole lot, and she wanted me to use Graal here, but not only did I run out of time here, I also ran out of time to prepare it. But she presented Graal this morning. You could also do this. You could turn this to a native image and launch this in no time. So that's all cool. So you can go. We basically showed you this project works as just source file for experimentation. It works as an installer on Windows. It works as a native image, right? So you have a lot of variety. What to do even after you're done. So we've seen great domain modeling, I think, with records and sealed types and pattern matching, easy, structured, and highly scalable concurrency. We didn't see the scalable here, but I could have, on this machine, I can have 1 million virtual threads wait for 1 second, and it just takes like 6 seconds. Right, so the overhead, like 1 million actual threads will definitely either fry the JVM or worse, maybe the OS. I'm not sure. I never tried. Do you know, who knows Heinz Kabutz? Heinz Kabutz? He does like performance stuff. He once had a live stream where he said, while true, new threads start. And I think the live stream ended there. So that's why I never tried. We saw the onboard HTTP client and a simple web server. We set some easy experimentation, packaging, and the native image we didn't see, but that also exists. And with all of that, I want to thank you very much for your attention.